Okay, I really need you to watch Miss Castra's video, and while you're doing this handout, here is her link. Um, you can simply go to YouTube, type in Annika Castro, slope fields and Euler's method, and she talks about this. I did screenshots of the Desmos activity. These are all from the Desmos activity, but I'm gonna kind of show you. These are the things that she walked you through and wrote down. I just want to make sure you have it all. Um, she kind of walks through this whole part, and here we had a step size of 1. That means we went over 1, and then we did our change of y. We went over 1, we went over 1. And then here we had a step size of a half, and she explains this in great detail. You need to watch her video. And then she may have mentioned this or not. What do they have in common? What's different about them? So they both kind of go up. What's different? This one has a lot more points. One of them is going to be more accurate. The one with the smaller, more points is more accurate. Okay, now our equation here is dy dx equals 1 over x. Okay, so from an earlier chapter, we know that if I have dy dx, if I have dy dx equals 1 over x, I can I can divide both sides, multiply both sides by dx, and I would get this, right? I would get this, right? If I multiply both sides by dx, and then if I take the antiderivative of both sides, the antiderivative of dy is just simply y. The antiderivative of 1 over x is natural log of x. And if I plug in 1 in for x and 0 in for y, then I get c is 0. So if my slope is 1 over x, then my original function is natural log of x. So if I plot these points here, this is the actual answer using the fundamental theorem of calculus. So if this is my actual answer using the fundamental theorem of calculus, and if I've used my step of 0.5, we got at for f of 4, when x is excuse me, when x is 4, we got a value of 1.59. Excuse me. Okay. We got a value of 1.59. Right? I should have used a different color. Oh well. And when we do the fundamental theorem of calculus, when we took the differential equation and found our value at 4, we know that the answer is 1.38. So I could use what we learned last year or the year before. I could find out percentage error by doing the approximate minus the exact answer. divided by the exact answer. Okay. And that is, you got to watch Miss Castro's video. This is just kind of a summary of what's going on.